So, what number represents owing $8? What is it, Miles?
Negative 8.
-8, because when we owe money, it's in the negative. It's called a deficit, like a debt. What number represents having $5? Raphael? 5, +5. So, who has the most money left? Who has the most money left? Trey? Berto. Because look, on the graph, his is the highest, and right there, he has about $5. So who owes the most? Who owes the most, Andrew? Myron. And how much does he owe? Yeah, he owes that $8, and Berto has that $5. So basically, if I have $10, but I owe Miles $3, I have to give him that money back. It's a subtraction problem. That's why we can just look at this individual part of it and see the -3. I want you guys to copy this into your notebook. It's on page 346. So, positive whole numbers. This word is important. Whole numbers. Their opposites and 0 are called integers. To represent data that is less than 0, you can use negative integers, just like we saw earlier with -8. That's still an integer. A negative integer is written with this subtraction sign because we're taking it away. Data that is greater than 0 is represented by positive integers. In that case, we don't necessarily need to write that positive sign because since it doesn't have the negative sign, we know it's positive. So, can 3/4 be an integer? Can 3/4 be an integer? What do we think? Raise your hand. What do we think, Fernando? It cannot. Only whole numbers are integers. Only whole numbers are integers. We have other words for different kinds of numbers, and quite frankly, I hate them. So here's kind of how it goes, and it's a little annoying. First, we have real numbers. All numbers are real numbers in a sense. Then, with real numbers, it splits out into irrational numbers. Irrational numbers are numbers like pi, are numbers that go on forever. It doesn't necessarily matter to us right now. It doesn't matter to us right now. Then we have rational numbers. In rational numbers, we have fractions and integers. So they're both considered types of rational numbers, but they are their own thing. Then in integers includes negative numbers, positive numbers, and 0. And they have to be whole numbers. These ones have to be whole. Now, fractions also include negatives and positives. Positive numbers are called natural numbers because they exist in our natural world. Negative numbers are pretty much man-made. Think about it. Negative apples. That doesn't happen. If we eat all of our apples, how many apples do we have left? 0. That's right here. Negative. If you borrow an apple, there's still no such things as negative. You owe them an apple, but there are no such things as negative apples. How about this? Shh. Quiet. So, let's think about this. We're going to write an integer and then explain each situation. We're going to explain the meaning of 0. So, Andrew, a 10-yard loss in football, a 10-yard loss. What integer would we use for that? What integer would we use? If we lose something, it's negative. So if 10-yard loss, because it represents a loss, the integer is -10. So in this situation, what does 0 mean? In football, what does 0 mean? What does it mean, Rocco? Yeah, no gain, no loss. So in 0, it means no yards are lost and no yards are gained. We just didn't move at all. What about this next one? 4 inches of rain above normal. What would our integer be there, Anita? +4. So, because it represents above, the integer is 4. Similarly, what does 0 represent in this case? What does 0 represent, Hannah? Yeah, the normal. Because that's the normal amount of rain is 0 rain. When it rains above normal, that's when we get rain. Is it possible to rain below 0? If it's snow, that's still not below 0. But no, we can't negative rain. We can't negative. A $48 deposit into a savings account. What is a deposit? Is a deposit an increase or a decrease, Lucy? It's an increase because we're putting money in. So if it's an increase, what's the number going to be, Andrew? What's the number going to be if it's an increase? Is it going to be positive or negative? It's going to be positive, and it's going to be $48. In this 0, what does the 0 represent? What does 0 represent in this situation? What does it represent, Michelle? Yeah, that there's no change in our account. There's no money in our account at all. It just represents that there's no money. There's no money. I want you guys to do A and B on page 346. This is going to be pretty easy. A and B on page 346. For A, a gain of $2. How do I write a gain of $2? How do I do that, Rocco? Yeah, just 2. Do we have to write a positive sign? No, it's just inherent. What about this one? Andrew, 10 degrees below 0. Negative 10, because we've gone below. What that means is if we had 0 degrees, we went below, so we subtract 10. 0 minus 10 is negative 10. Exactly. Now, using examples number 4 through 6, I want you to solve C and D. Using the examples 4 through 6 on page 347, I want you to do C and D. So, negative 3, that just goes right there. 0, there. Negative 2, 4. Pretty easy, right? This one, 8, it goes here. Negative 6, it goes here. Negative 9, it goes right here. And 5, it goes right there. Notice that these look really similar to the coordinate plane we did before.
Yeah.
What would this axis be? What would this axis be, Elsie? The x-axis. So which would this axis be, Nathan?
Y-axis.
The y-axis, exactly. So go do the guided practice 1 through 5, and then you can start your homework, okay? Go do the guided practice, and then you can start your homework. So, a 15-yard gain. What's our number for a 15-yard gain, Rafi? What is it? What do we think a 15-yard gain is going to be? What do we think, Rocco? Yeah, just 15. What would 0 mean? What would 0 mean? Andrew? Hold on. What would 0 mean in that first one? What would 0 mean in the 15-yard gain? Trey? Yeah. In 0, no gain or loss. So, what about a loss of 2 hours? What is that, Andrew? Negative 2, because we've lost 2 hours. It also 0 would again mean no gain or loss. No gain or loss. So, when we graph, this is just an introduction to when we're doing graphing and stuff. This is just an introduction to doing graphing. Even if you're still working, I want you to work with a partner on page 354. 354. This one's really easy. This part's really easy. Ready? So, what's the distance between 7 and 0? What's the distance between 7 and 0? Rocco? 7. What's the opposite of 7? What's the opposite of 7? Hannah? Negative 7. Hey, what's the difference between negative 7 and 0? Negative 7 and 0. Matthew? 7. Exactly. Just like when we look at our graph here, this is 0, 1, 2. This is negative 1, negative 2. Look at the difference. From 2, it's 1, 2 hops away. From negative 2, it's 1, 2 hops away. Even though it's negative positive, it's always the same amount of hops away. So, the distance between negative 11 and 0. What's the difference between negative 11 and 0? What's the difference? Rocco? 11. What's the opposite integer? Between negative 11, what's negative 11's opposite integer? 11. What's the difference between 11 and 0? 11. You see how easy this is?
Yeah.
The distance is always positive. Distance is always positive. As such, what can you conclude about the distance from 0 for both an integer and its opposite? What do we know about the distance? The distance is always, Elsie? It's always positive, and it's the same. Negative 3 is 3 hops. 3 is also 3 hops.